Let's see who we've got in the room today. All right, I'm gonna go up here and then see who we've got. Oh, what is that sound? Just heard some music. Oh, what is that? What is that? Hi. Hold on. I'm hearing something. What is that sound? What is that sound? I'm hearing something. Hi, everybody. I'm about to get in this room in a second. I'm going to talk to all of you guys. I'm pulling up this video. So here we go. Oh, I'm hearing an ad. So it's my noise cancellation. Hi, everybody. Hello, world. It's Siraj. And today we're going to create a two-layer neural network. Let me just get this ad out of the way. All right, there. Okay, here we go. Okay, so I'm in the room and I'm ready to go. Hi, everybody. Okay, that was crazy. Okay, so I am live and there are 83 people watching right now. And hello, everybody. Hi, Andre. Hi, David. Hi, Prakar. Hi, Yasu. Today is Wednesday. MNIST. No, it's not MNIST. Okay, so here's what we're going to do. We are going to make a two-layer neural network from scratch that can predict the XOR value, okay? So what does XOR mean? That means we're just gonna give it an array of numbers. Okay, so that means it's gonna be ones and zeros. I'm not gonna use Theano, I'm not gonna use TensorFlow, I'm not gonna use anything but NumPy and the time library. We are building this thing from scratch, just a two-layer neural network. No scikit, nothing. Because people have been asking me to build a neural net from scratch for a while, so I'm gonna do it, okay? And so, a disclaimer, okay? So like, I've made a video on building a neural network before. I know you did that in kindergarten, that's awesome. But Parker, Aliaba, Us, Mitchell, I'm just gonna keep shouting out. I've built a neural network before in a video called Build a Neural Net in 4 minutes, and it's my most viewed video. But that was like a pretty easy, neural net. This is the first time I'm gonna say that this is gonna be a little bit intensive. It's gonna be a little bit of math. There's gonna be quite a bit of math in here. So this is not going to be dead simple. I'm just gonna say that for the first time because you guys wanna build a neural net from scratch, so like, let's just go, you know what I'm saying? So, okay, here we go, we're gonna do this. And so it's gonna predict the XOR value, okay? So we're gonna give it ones and zeros, and then we're gonna generate some random data, and we're gonna compare them. So it's like XOR means in computer science, it's like exclusive OR, which means it only returns true if they're both different, like OR. If it's a 1 and a 0, oh, it's a 1. If it's a 0 and a 1, oh, it's a 1. If it's a 0 and a 0, it's a 0. If it's a 1 and a 1, it's a 1. It's a 0. Okay, so exclusive OR. All right, so that's what we're gonna do. And I'm gonna start off by doing a 5-minute Q&A like always, and then we're gonna get right into the code, okay? So ask away, 5 minutes starts now. Where do I work? I don't work for anybody, although I do have a video coming out for OpenAI, which I'm super psyched about. Can't say anything about it yet. Anyway, how do I learn math for machine learning? Linear algebra specifically and statistics. Udacity has some great courses on both of those things. What do you think of microdosing LSD? I think it's a great idea, but you have to have a friend with you. What are your thoughts on the Udacity Nano Degree in Machine Learning? Great course. What Linux distro do you recommend? Ubuntu. How long have you been coding? 6 years, but only seriously like 3 years. How can we help you other than with money? Please promote my videos seriously. Like, get people to subscribe to my videos. Like, I feel like I put all my time and energy into these videos and I don't have nearly as many subscribers as I want. So anything you guys can do to get people to subscribe would be super helpful. When would you use a neural net over a random forest? Oh man. Just go by this simple rule of thumb. A deep neural net will outperform any other machine learning method pretty much 90% of the time at least. So if you have a lot of data, use a neural net. If you don't have a lot of data though, if you only have like 100 samples, then I would look into a random forest. BigML.com does that for you. Okay? What's your goal with YouTube? I want to be a public figure. I want to be the face of machine learning, the face of artificial intelligence, the face of computer science. And I want to use YouTube as a platform to get this stuff out there and get everybody building AI and building intelligent software. All right? Can you tell us how long will this live stream approximately be? This is going to be about 30 to 40 minutes. What is the coolest AI ML project you've come up with? I think building an AI composer, it's my second machine learning for hackers video. Build an AI composer was like my favorite project because you generate music with machine learning. How cool is that? Why didn't you try for master's and PhD? Well, I mean, my parents definitely wanted me to have a master's and PhD, and they still kind of do, and they always will. But I'm just gonna keep doing this because I have the time to do this. I can study on my own, and I have good advisors more or less. So I'm kind of doing a PhD, but it's like not an official. It's like a new thing, and I just don't want to have to deal with the bureaucracy of academia. Not to say all research labs are bureaucratic, but most of them are. Please try to make these a little early for us here in India. I can do it 30 minutes earlier, and much love to everybody in India. More D3 videos, please. Okay, I can, yeah. All right, good to know. Bose QC35 headphones, exactly. It's, where did you go to school? I went to Klein Oak High School in Houston, Texas. That's where I grew up, and then I went to Columbia University in New York City, yeah, for undergrad. Do you believe academia is the best path for learning machine learning and AI? Man, that's a great question. I think anything that could give you the time and the time to study machine learning on the internet is the way to go. So if that means academia, if that means you get a scholarship and they're paying for your housing and they give you a little stipend so you can eat, that's the best way. But if you can make money otherwise and then you can just like live, like, you know, do some contract work, then you can, you know, then that's what I did. I just made some money doing contract work for mobile development, and I used that money to just live and study machine learning on the internet. I can't do classes in real life. I can't pay attention to professors who just go on and on and on, and they just, you know what I'm saying? So I just want a 2x button, 3x button on life, and the internet is the way. People ask me this question all the time, like, how did you learn machine learning? What is the way to do this? And I just tell them every time, the internet. The internet makes everything obsolete. Colleges were invented before the internet, and that was the way to do it, and they were centralized. But now with the internet, anybody can learn anything online. So I watch videos very fast, and I look at other sources like Reddit and Twitter feeds. I follow people like Balaji Srinivasan and the whole Andreessen Horowitz team. So I have a lot of data inputs. I'm going to have one more question, and I'm going to get started. What's the best entry point for people that are relatively new to machine learning and AI? My videos. Start from the very beginning and download the code for each video and run it locally and get it to work and study it. I promise you, you will get to be a pro in no time. Okay, so that's it for the questions. Let's get started. We're going to build this 2-layer neural network, and it's going to predict the XOR output. All right, I'm going to help. So here I go. I'm going to share my screen, and we're going to get started. Here we go. Screen share. Desktop, start. All right, I'm gonna move this out of the way. And boom. Let's see, you guys can see all this. All righty, great. Cool, 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 cool. All right, so let's get started. This is a big enough thing, yeah it is, okay. So it's a 2-layer neural network. Okay, so here we go. Let's get started. So the first thing we're going to do is import our dependencies. The first dependency we want to import is NumPy, which is our scientific computing library. NumPy is going to let us do all of our matrix multiplication, which is very important in neural networks. Matrix multiplication is very important in neural networks, and I'm going to explain why. So that's our first library, and our next one is going to be time, and time is going to help us time how long our training is going to be. Okay, so that's it. That's all we're going to that's the only libraries we're going to import. Okay, so let's just get started. Let's go ahead and start defining our variables, okay? So the first one we want to define is our number of hidden neurons, and we're just going to say 10. Why? Because we're going to have 10 values, like ones and zeros, an array of ones and zeros, that we're going to input into our network. And we want to compare it to 10 other ones and zeros, and then output the XOR value. That's what the output's going to look like, just ones and zeros, 10 of them, okay? And so now we want to show the number of inputs. How many? 10. So there's 10 neurons, and it's 10 inputs. And then how many outputs do we want to have? Well, we want to have 10. Glad to have you here, good vibes. All right? So here we go. So we want the number of outputs to be 10, okay? And then one more thing, we want sample data. How much sample data do we want to have? Well, let's just have some really big number, and we're just gonna pick 10 of them. So what's a big number that we can pick? And we're just gonna pick 10 of them. Let's do, this is a neural network for classification, yes. We're gonna pick 300, all right? 300 sample data that we're gonna generate. Okay, so that's it for our variables. Okay, so now we're gonna define our hyperparameters. What are our hyperparameters gonna be? Well, the first one is gonna be the learning rate. And the learning rate basically defines how fast we want our network to move. And these are tuning knobs. We can make it go faster or we can make it go slower depending on what we want, okay? So that's our learning rate. And there's one more tuning knob. There's one more hyperparameter that we want in this model, and that's called momentum, okay? These are two different variables, and we're gonna use them both to lower the loss function, which is going to be called cross-entropy as we train our neural net, okay? Those are the only two hyperparameters that we're going to use, all right? So those are our two hyperparameters, and that's it. So now we're going to generate a random sample. Sorry, now we're going to seed our, random number generator. What does this mean? Well, we're about to generate some random data, right? And we want to make sure that every time we run this code, it generates the same random numbers every time. Why? Because we want to test the code, right? And so that's what seeding does. Seeding makes sure that we generate the same random numbers every time we run our code. Okay? So that's it. So let's seed this. Shit. Okay? So there we go. You know what? Let me be a little more descriptive. Non-deterministic seeding. That's the technical term for this in computer science, right? And I did a video on, I mentioned non-determinism in my P versus NP video. Okay, so so we have that. Can someone say how many people are in the room? It's kind of it's blocked. Okay, so we've got the sigmoid. So now we've seeded our numbers, and now we're going to define our activation function. The traditional thank you, good vibes. The traditional activation function that we use is the sigmoid function. So let's write that out as a function, right? And so sigmoid is the function that's run in every neuron in our network. So what does sigmoid look like? So let me just write out this formula, and my videos should be watched in order, absolutely. Honestly, if you were to watch all of my videos from like the very, very start, like the what is Bitcoin video, you would learn so much. I literally put everything I've learned into these videos, like literally everything I am into those videos. Okay, so what is a sigmoid function? The sigmoid function turns numbers into probabilities. Okay, they turn numbers into probabilities. What does that mean? Well, in our neural network, when we have our input data, it goes through the network, and each of the weights is a set of probabilities. Like, which way should it go? 0.7% this way. Oh, 0.6% this way. Oh, 0.3% this way. Output. Okay, and so probabilities, and these probabilities are updated when we train our network. So it gets better and better over time. So that's what the sigmoid function does. Every time our input data hits one of those neurons or one of those layers, it's going to turn that number into a probability. That's all it does, okay? So traditionally we would just use one activation function. We call the sigmoid the activation function. But this time we're gonna use two activation functions. Why? Because it's for XOR specifically, the tangent function is helpful because it just makes the loss even better than if we were to use just the plain old sigmoid. And I'm not going to go do like super simple. So I could just use a sigmoid, but I want to be accurate, right? I'm going to make the most accurate neural network that I can from scratch, okay? So I'm going to use two activation functions. One is going to be for our first layer, and the other is going to be for our second layer, okay? So let me just write that down. And so this, whatever it's returning is the actual function itself. It's the programmatic function of the math function of the tangent prime function, okay? So those are our two activation functions, right? Okay, so that's it. Those are our two activation functions. So now let's write our training function, okay? So I'm gonna hit enter. I'm gonna like move up. So just take a screenshot. Okay, 3, 2, 1. Here we go. Okay, so I'm gonna go down, and now I'm gonna write my training function. So def train, and so the training function is going to write. Gaussian. It doesn't make a difference if it's a 1 or a 1.0. You're absolutely correct. So the training function is gonna take 5 parameters. I'm gonna write them, and then I'm gonna explain what these parameters are. Okay. Okay. BV, BW, BW. Okay. Okay, so what are we doing here? So what is the X? The X is the input data. The V is our transpose, which is going to help us perform matrix multiplication. The V, sorry, I missed something. Let me start over. The X is our input data. The T is our transpose, which is going to help us perform matrix multiplication. The V and W are our layers to our network, our 2 layers, and BV and BW are our biases. Our biases are going to help us make a more accurate prediction, okay? And there are going to be 1 bias for each of the layers in our network, okay? So those are our inputs. So let me just write that. Input data, transpose, layer 1, layer 2, and then biases, okay? So let's just do this. So the first one is going to be forward propagation. So we're going to do matrix multiplication, matrix multiply plus our biases. Okay, so let's do this. Okay, so we're gonna so let me just write this, and I'm gonna explain it right after I write this. Okay, so np dot dot. So I'm gonna do matrix multiplication, do the dot product, and then let me write one more. And then do the same, but this time use our tangent function. Okay. So let me explain this. Okay, here we go. I am going to randomly shuffle the data, and so this is going to be a simple perceptron. Yes, top 1%, exactly. You can call it a perceptron. You can call it a feed-forward neural network. It's a clever rebranding that they call it all deep learning, but you know, this stuff has been around since the 50s. We just now have all this amazing data and compute, and that's why it's awesome. Okay, so here's what we're doing. This is forward propagation, okay? We're taking the dot product of the input data, X, and we're putting it into our first layer, V. The dot product is computing that matrix multiplication, and it's adding the bias in to get that A delta value. Then we're gonna perform that first activation function. That's the first time I've been called the Beyonce of neural networks. Thank you. That's pretty good, actually. Okay, so then we're gonna perform our activation function on that data. Okay, so that's our first operation. The next one is going to be now we're gonna have to do our sigmoid function. Okay, so we already applied our first activation function. Now let's apply our next one, which is going to be the we're gonna take the value that we just created, Z, that delta, and then we're going to add that the next layer, right? The second layer, W, and we're going to perform the dot product. So we've computed the first part, and then we're going to take that result, and we're going to compute that next layer using the result, using the dot product. Okay? So, oh man, okay. So, so now we're going to add our next bias, right? The bias for that. We just need to do this twice, right? We did it once, and now we're going to do it this next time. So, and we're going to calculate that sigmoid using that value that we just had, and we're going to call it Y. We're going to call it Y. Okay, so that's our forward propagation. So that goes forward. And so when we have a feed-forward neural network, it's not recurrent, but we do have something called backwards propagation. So it goes forward and backward. It doesn't go loop. It just goes forward and backwards. So what does that mean? We update our weights one way, and then we update them backwards. And we just keep doing that while we're training, okay? So let's do backward propagation. Backward, so say backward, okay? So let me just write this, and then I'm gonna explain it. It's gonna be 2 lines, okay? So let me get some of that coffee in, you know what I'm saying? That stuff helps. There you go. All right. MP.product. EW. Okay. Okay. So yeah, these are our 2 deltas that we're getting for our backward propagation, and that's why we use our transpose. Our transpose is basically our matrix of weights flipped, and we flip it because we're going backwards, right? We make the matrix itself backwards of values, and then we use that to calculate our backward propagation. Ultimately, we want this EV value, okay? And what are we going to use this value for? Well, we're going to use it to predict our loss, and we're going to compare our predicted loss function from our actual loss function, and we're going to minimize our loss doing that, okay? So that's the goal. We want to minimize our loss. That's how we train. We want to minimize our loss. Hi, Panagiotis from Greece. That's an awesome name, okay? I love Greece. Okay, here we go. So let's predict our loss. Predict our loss. Okay, so to predict our loss, we're going to calculate we're going to take, let me just write this out. And could someone shout out how many people we have in the room right now? EV, we want to predict our loss. Okay, so what we're going to do is predict our loss. And these are 2 deltas. And we're using both of these values. We're using the Z value, okay, that we predicted from up here at this forward, thank you, from this forward step. And then we're going to use the X value, which is our input, okay? And so there's that. And so now we're going to calculate our loss, okay? Thanks, guys. So now we're going to calculate our loss. So this is going to be quite a long line. So let me just write this out. And you know, in TensorFlow, in a bunch of libraries, the loss function is just a line of code. You know, like you just say loss parameter. But we're doing this from scratch. So we're going to actually use the math here. So let's go ahead and say, and I have something to say about this as well. About using math and machine learning and if you should learn it or not. And what the point, okay, so let me just do that log, what was it, 1 minus y, okay? Let me make sure that this is correct. Loss is the negative of the mean of the transpose. We take our log function of y, and we add 1 minus the transpose. Okay, so this is called cross entropy. This is a Mikhail, I would do a meetup for sure. Yeah, you know, I should do that. I had a talk yesterday. One of my fans asked me to have a talk at SF State, and I did that. But there weren't that many people. I mean, there were like 15, but like, dude, there's like 168 people here. You know what I'm saying? Live is awesome. But yeah, if there were enough people, I would totally do a meetup. Yeah. I'll look into organizing that. Or if you would look into that, that would be super helpful as well. Okay, so here we go. So this is cross entropy. Okay, so why cross entropy? Well, there's a bunch of different loss functions. There's the mean squared error. There's a bunch of different loss functions, but we're using cross entropy because we're doing classification. Generally, if you're doing any kind of classification task, you want to use the cross entropy function. Why? It just tends to give us a better result. Okay, and then one more thing about using math and machine learning. This is a long function, and it's kind of difficult to understand. Do you need to know the math to use machine learning to get good at machine learning? And my answer is no, but it helps. No, you don't, but it helps. Because if you ask some of the best JavaScript programmers in the world, right? If you ask some of the best front-end designers in the world, they make the websites like Airbnb, like Stripe, like, you know, the best designers in the world. How, like, if you ask them to make a rectangle, they'll just do like, you know, make rect or some function. But if you ask them like the details, the mathematical details, the pixel values, and you know all the math that goes into making a rectangle, they won't know. all of this is a series of abstractions. It's just series and series of abstractions. Eventually, we won't even need to know. We won't even need to know what cross entropy or any of these functions are. Eventually, we won't even need to know programming. We'll just tell it what we want it to do, right? So it's just a series of abstractions. We're all building on top of each other, right. So I don't think it's necessary to know the math to do this, but it helps. Okay, that's it. Exactly. Don't reinvent the wheel. That's it. Okay, so here we go. So that's a cross entropy, right? So we calculated all that. So let's do our last line of this is going to return. We have to return our loss function. Okay, so we're going to return our loss function, and we're going to return our delta values and our errors. Right? They are errors and our deltas. Okay. So okay, so that's it. That's it. Okay, so that's it for our training step. So screenshot that. I'm gonna go down a little bit more. 3, 2, 1. Boom. Okay. All right. So here we go. So now let's write our prediction. So we have one more function to write, and then we can go ahead and get started with our actual the meat of our code. So we have one more function to write, and it's going to be the prediction function. This is going to predict our value. Okay. So let me write down the variables, BV and then BW, BW. All right. All right. Okay. So hi, Cooley Smiley. Wow. All right, we got some non-ML people in here. Okay, here we go. Everybody say hi to Cooley Smiley. She was a YouTuber that I met in LA. Okay, so here we go. So we're going to do a prediction step. Okay, so what does that mean? That means we are going to perform matrix multiplication to predict our value, our end result. And to do that, we're going to use these variables that we've already calculated. np.dot. Oh my God, I need to just say this. Amadeus said, when I'm on a date, I don't need a neural network to predict my loss. That is gold. That is gold. That is gold. Okay, so let me write, it's just gonna be 2 lines. It's gonna be 2 lines, all right? So let me write that out, and then I'm gonna explain it. Like, what the heck is happening there? And then we're gonna return it, and we're gonna use our sigmoid function to it's got to be greater than 0.5 as type int. Okay, so here we go. Okay, sigmoid. What's happening here? So A and B are both of the final values that we're calculating using those variables that we've already used in our network. Okay, and we're using and we're going to return whatever we return is going to be our prediction. And what is our prediction going to be? It's going to be a number. It's going to be a 1 or 0. Okay, and we're saying only if the value is greater than 0.5 do we return. Sorry, if our value is greater than 0.5, it's going to be a 1. Else, it's going to be a 0. And 0.5 is just a prediction. It's the probability. All right, Tejas. All right, good point. Good point. Okay, so here we go. Oh, thank you, AskHud. All right, so that's it. Those are our functions. Let's go ahead and get started. So we're going to set up our initial parameters. So we're going to create our layers. So let me create the layers. Now it's time to create our layers. Okay, so let me go ahead and do this. Okay, so here we go. So B equals, so our first layer is going to be random.normal, scale equals 0.1, size equals number of in, number of hidden. And then, so that's our first layer. And now let's make our next layer. Remember, this is a 2-layer neural network. Okay, it's just 2 layers. And we're going to create them both the same way. Okay? And I'm going to explain why we're using these variables as our size right after I finish typing this out. Okay? There we go. 2 layers, V and W. And we're going to, so the size is basically the number of input layers, which is number of input values, which is 10, and the number of hidden layers, which is 10 as well. Okay? So 10 in and then 10 out. Okay? Every time. Where's the stripe in your hair? It's there. Oh, see, I need to make it more gray. Okay, it's there for sure though. Definitely check that out. Okay, here we go. So here we go. Here we go. We're going to say, all right, miss you too. We're going to say, we're going to calculate, we're going to create our biases. Okay, we've used our biases in the parameters, but we haven't actually initialized our biases. So let's use our biases, okay? So we're going to say our first bias is going to use our hidden variable as a parameter, and then we're going to use our next bias, which is going to be our next value is going to be the number of output layers, okay? Okay. So those are our biases, okay? And now we're going to generate our data. We've created our layers, we've created our biases, and now we're going to create a variable called parameters, which we're going to input as a parameter. It's going to be an array. It's going to be an array of all of our values that we've just created, our two layers and our biases. It's just going to be easier to input it into our training function whenever we call it. My hair is totally open source. If you guys want to have a silver stripe in your hair, go for it. But just like, you know, you can credit me if you want to. I don't care. Everything about me is open source. Take my ideas, take my everything. I'm open source. You know what I'm saying? So parameters and oh man, it's really hard to not reply to comments because you guys are so awesome. I don't want to not talk to you, right? All right. So we've created our parameters. Let's generate our data. Okay. X equals np.random. .binomial. All right. So we're going to generate our data, and so this is why this is where that sample of 300 variables. This is where it's going to come into play. This is why we initialize it so that we could generate data. We're going to generate 300 samples, and I'm going to use a learning rate in a second, so we've generated our data, and so now we're going to calculate our transpose, right? Guess what? Guess what, guys? Guess what? It is time. It is time to train this ish. Okay? It is what I call training time. It is training time. This is going to be awesome. This is our last step. It's a for loop we're going to train. Okay? All right, and I'm going to get better at the video quality, and I'm going to get better at everything, so just everyone relax. So here we go. So training time. We're going to train this for 100 epochs. Okay, so for every epoch in the range of 100. So we're going to do this for 100 epochs. Okay, everybody say hi to each other. Everybody's cool. Okay, so we're going to start off by initializing our empty error array, which we're going to add data to in a second. And then we're going to say our update variable is going to be the length of our parameters that we just initialized up there. And we're going to also initialize our time, because we're going to time how long we want to run this neural net, okay? We're going to time it. And so that's where that second variable, that second dependency time comes into play, just for this. Okay, so now let's do this, okay? Like for each data point, we want to for each data point, we're going to update our weights of our network, okay? We're definitely still fighting. So the neural network is to find the XOR value of ones and zeros. Okay, so for each data point, we want to update our weights. Okay, so we're going to say for every value in the range of our input data. Okay, so and how do we say how big our input data is? We use the shape function of x. Okay, so we're going to say we're going to take our loss function. We're going to calculate our loss and our gradient by doing what? By using the training function that we just calculated, right? That we just initialized and declared and then created. And that's where our parameters come into play. Just for simplicity's sake, we're just using params instead of saying xv, bv, bw, just say params. Great thing about Python. Okay, so that's us calculating our loss and gradients. Now we want to update our loss. Well, how do we do that? Well, we're going to have two more little loops here. Okay, so we're going to say for j in range of the length of the parameters, params j minus equals update j. Okay, and so I'm going to do one more, and then that's going to be it. That's literally it. I'm going to explain what I'm doing and why I'm why I'm doing it. Okay, so so this is where our learning rate comes into play. This is where our momentum comes into play. Both of those hyperparameters that we initialize, this is where we actually use them. So learning rate times gradient plus momentum times the update value that we just calculated. Those two for loops are going to help us calculate our loss. That's going to help us calculate our loss, okay? And then we want to append our error with the loss. That is it. That's it. What am I doing here? Dot. Okay, cool. Save. Okay, so that's it. And now we're going to print that value. It's 35 minutes in, okay? How many people we got in here? Someone shout it out. So now let's print out our results, okay? We're going to print them out. Epoch. And so I'm going to print it out using %d, %d, and then, okay, cool. Loss is going to be %.8f. We're going to print out our loss. We're going to print out our time, like how long has this thing been going on. And then we're going to say %. And then we're going to say epoch. We're going to print out our epoch. We're going to print out our loss, which is going to be the mean value of our error. And then the time, which is going to be time.clock. And % minus that starting point. So someone check this and make sure that I don't have any errors in my syntax on this line. Epoch, loss, time, point, right, 0.4. Okay, F, S. I think that's good. Oh, and so then that looks like typo at line 83. Line 83. What is my typo? My typo is lens is length. Thank you. Okay. So, okay, that's it for our training function. Let's go ahead and try to predict something, okay? So say try to predict something. How do we do that? Well, we say, okay, let's say X is going to be a random value, a binomial value, between 1 and 0.5. And how many of them? We want 10 of them. Okay, so we're going to try to predict something. We're going to try to predict the XOR prediction. Okay, go. Okay. Well, we got to print that X value. Like, what are we going to predict? And then finally, our prediction, which we use our predict method for. Let's go ahead and demo this baby, okay? And our parameters. Boom. That's it. Let's see what is going on here. Let me run this. All right, bye. Can anyone see this? I can see this. Okay, so let's go ahead and run this. Okay, so I've got number of samples is not defined. Number of samples is not defined. Okay, so on line 67, number of samples is not defined. Oh, did I not define that? What? I did. Oh, you know what? It is a boom. Oh, yes. It is training. It is okay. Yes. Okay. So what just happened? What just happened is I only had a single error and I fixed it. Anyway, so this trained for 100 steps, and you guys are so nice. You guys are awesome. So I know, I got to calm down. I'm just like really excited that this worked. So what happened? That first line right here. Let me make this bigger. Make it a lot bigger. Let me make it a lot bigger. That first line is our input data, right? And this next line is our XOR values. Those are our XOR values, okay? And we basically said, here's our input data, here's some randomly generated ones and zeros, and then compute the XOR, and then get better and better over time. And as you can see, our loss function is getting better over time. See our loss function, 0.14, you know, and then 1.3, and then way up here it's like 36. And so it gets better. It's timing it. It's timing the epoch when the code works. It's alive. It's smart. It works. That's our XOR value. Okay, so I'm going to end this with a 5-minute Q&A, and I'm going to post the code on GitHub. And guys, please share my videos. Like, I'm trying so hard to hit 50K subscribers by January 1st. So that's the best thing you can do for me is hit subscribe. Get your friends to hit subscribe. I'm going to make so many videos. I'm like just getting started, okay? So 5-minute Q&A, and then we're out of here. Thank you, Voice in the Box. Thank you, Sudarshan. What am I trying to predict? Trung, I'm trying to predict the XOR value. All right. Can I use a neural network to predict Black Friday sales? Yes, absolutely. Just look at a history of past sales and try to predict the future sale. You want to put that into a spreadsheet either manually, or I'm sure you can find that somewhere. Thank you, Johannes. I have not blocked you. Cross-entropy in NLP. Exactly. What's my favorite color? Sapphire blue. What's your name on GitHub? LL source LL. I actually rapped about my name on GitHub. If you looked, I have not blocked you. I have rapped about my name on GitHub. Just look at my channel trailer. It's a. Do you watch The Flash? I don't, but I should. What would be your favorite company to work for? You know, man, I don't know if I could work for a company anymore. Maybe, I mean, the best one would be OpenAI, because it's awesome. That would be the one. Could you use a neural network to classify a multidimensional time series? Yeah, no, for sure, absolutely. A time series is sequential data, right? So you'd want to use a recurrent neural network. Are CNNs good for prediction? Yeah, I mean, for image, actually CNNs have been used for text prediction as well. Like what's going to be the next, they've been using NLP. Will you buy the MacBook Pro 2016 with a touch bar? Yes, I have it. I have it right here. But guess what? It's got USB-C ports, and my display doesn't use USB-C. There's a little touch bar, so I had to use my old MacBook. So that sucks for Apple, right? I did say DeepMind, but like, I mean, they're both good. They're both good, but I like OpenAI's openness and democratizing thing. Value. How old am I? I'm 25 years old. Are you an AI or Sirajology? I am myself. I am Siraj. I'm all Siraj. Siraj. 2 more questions and we're out of here. How did you get into CS? I couch surfed in London. I met a guy named Alex McCaw. He was the dude who was like, hello, mate, I'm coding. And I was like, yo, this text editor you got here, it's so pretty and colorful. I want to do stuff like that. It's like, yeah, I'm really envious of you in San Francisco. You can make a lot of money and do great things. And from then on, I was like, I got to be a computer scientist. I was 19 years old. I was an economics major at the time because all I cared about was money. And then I was like, wait a second, there's more to life than just money. All right, so one more question. When are you, oh, here's a good one. Can we use neural networks for AGI? That's a great question. Who knows? I mean, yes, I mean, just the idea of a neural network, our brain we know it's a neural network, but like gradient, does our brain use back propagation? Does our brain use gradient descent? Is our brain using recurrent networks? Is it using convolutional? It's like all these different type of networks. We don't know, but we're getting really close, and the state of the art is being broken at an increasingly fast rate. Every day, deep learning right now is where physics was in the 1900s. The Einsteins and Newtons and Marie Curies and famous scientists of computer sciences are alive right now, or they're in middle school or elementary school, or they're in the field. So it's a very, very exciting time to be watching, and awesome. So that's it for this tutorial. Thanks everybody for watching. I'm going to have my video come out very soon on Friday, and then a very, 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 very special video that's going to come out on Monday, and it's going to be awesome. It's going to be awesome, okay? It's going to be the video I've been most excited to make ever. All right, so thanks guys for calling out the number of people here. Thanks everybody for watching this video. Thanks Brian, Christina, Aditya, Andre, Mikhail, Sudarshan, Ian, Elfish, Danny, Top 1%, Multi-Shiv, Vyas. You guys are awesome. Thank you for watching. Please share my videos. I love you guys. And for now, I've got to write so many video scripts. So thanks for watching.